Okay, this is a video for those of you that missed the class on dividing polynomials. And I need you to get this sheet out, which I gave to you the other day, so that we can use it to do the work that you need to do so that you can understand what's going to be on the quiz. So let's move ahead. First of all, we're going to skip the essential questions. We're really going to go right into this. So if you can move to, I'm actually going to have you move to the end, than the harder questions. Someone asked when I did B, they go, well, why don't you just cancel out an X on everything? Well, the answer is you could, but this is a different technique that we're going to do. We're going to divide, in this case, just the X into the number on the top. So I'm going to go X goes into, so it says interestingly, X to the third plus 4X squared minus 2X. X goes into the X to the third, X squared times. X squared times X is X to the third. Draw our line and subtract. I get 0, which you don't have to write. They cancel out. And then I bring the next number down, 4X squared. You ask the question, X goes into 4X squared. I'll save you some time and just tell you that it's going to be 4X times. 4X times the X gives me 4X squared. Again, the exact same number. Subtract, I get 0. Bring down the next number, minus 2X. X goes into minus 2X, minus 2 times. Minus 2 times X is minus 2X, 0. So there it is. This is the answer to that division problem, X squared plus 4X minus 2. So at this point, I'm going to invite you guys to try your hand at the other questions. And, hopefully if you're in a math lab or something like that, you'll be able to get additional help if you get stuck on any of these things. But the process is the same. To page 6. Let's go ahead and take a look at F. Actually, I kind of like G. I like G because there's a coefficient in front of the X term, so it makes it a little bit more interesting. So let's set this one up. We're going to write 5x minus 7 goes into the 5x squared minus 17x plus 14. Again, we're going to start with the first numbers. How many times does 5x go into 5x squared? Well, it's a division problem. If I divide 5x squared by 5x, I get an x. Multiply it out. 5x squared, there's my check, it matches. 5x times a negative 7 gives me a negative 7x. I'm going to change the signs and add. That's the same as subtracting again. And I get a negative 10x. Bring down the next number, 14. Do the process again. 5x goes into negative 10x. Well, if you divide it in, it becomes negative 2. And now I multiply the negative 2. I get negative 10x. Again, they match. That means I did the right thing. Minus 2 times a minus 7 is plus 14. And these two numbers match. Therefore, their difference will be 0. So, as Mr. Hawk would like you to write, 5x minus 7 times x minus 2 equals 5x squared minus 17x plus 14. So anyway, an interesting process. This looks similar to factoring, and in many respects, this is one of the things that we use in the more advanced math to help us factor. So let me go to the first page, because at this point the first questions almost looks for pretty much all of them. If we, I think G is a great example. The first question is, it's how many times does the 5x go into the 5x squared? You write that number on top of here, and we multiply that x times everything. This is very similar to long division that you did in middle school. It's just that we do it, the long division now, we don't even think about what we're doing, but now you really do. So you multiply the x by those two numbers, remember to bring the 14 down, and then repeat the process until all these answers, all these division problems will come out with a remainder of 0. And that's thanks to Mr. Hawk too. Okay, well anyway, give it a go and see how things are. The other part of the quiz that you're going to be taking is a review that you will find on Big Ideas Math under the and you can you'll be able to find it on the Big Ideas Math site. So Big Ideas Math is going to review 4.1 and 4.2, and then you need to be able to do this polynomial division, and you're good to go. Well, anyway, I hope this helped, and I'll see you in class. Take care. Here it is. Yeah, I'd like to go ahead and move to the second to last page. And from here, I'm going to go over a couple things that will hopefully make some sense. But before I do, I wanted to digress just a little bit and go into the division that we do know. And the division that we do know is something along the lines of something like 13 into something like 286. So let's, this is something that you guys do pretty much automatically, but when we do polynomial division, I think you need to be a little bit more deliberate and understand the process that you use. So the first thing we do in long division is we ask, how many times does 13 go into 28? That's basically the same question as dividing 28 by 13. Now, division of 28 by 13, we know that 13 goes in 2 times. So we write down the number 2, and then after that we multiply the 2 times the 13 to get 26, and then we subtract, which is the same as, I sometimes say, changing the sign of the 26 and adding them. So 28 minus 26 is 2. Next step is to bring down the 6, and then we start over. 13 goes into 26. In other words, 26 divided by 13, how many times does it evenly go in? The answer in this case is 2. And again, I multiply the 2 times the 13, I get 26, and no remainder. Now what I'm going to do is create polynomials out of the 13. I'm going to call that 10 plus 3 and instead of 13. And instead of 286, I'm going to change that to 200 plus 80 plus 6. So in a sense, we have the same thing, but it's expressed differently. It's expressed as a polynomial. So this is going to be simulating what you're going to be doing for polynomial division. In polynomial division, though, we're only going to be concerned with the first numbers on the outside and on the inside. And so we're going to ask the question, how many times does 10 go into 200? And that, again, is the same question as 200 divided by 10. The answer is 20. So I put the 20 up here, and just like I do with long division, I now multiply the 20, not just by the 10, but also by the 3. So 20 times 10 is 200. And then the 20 times 3 is 60. Draw my line, and to subtract, I use the old idea of changing the sign and adding. So if I change the sign on both of these, I get 200 minus 200, which is 0. And then I get the 80 minus the 60 for a 20. Next step, if you recall, bring down the next number, 6. Now we ask the same question. We start all over. We ask, how many times does that 10 go into that 20? And the answer is twice. So I'm going to put a plus 2 up here. And again, multiply the 10 and the 3 by the 2, right? And I get 2 times 10 is 20. and the 2 times 3 is 6. And so that is I'm going to subtract in this case, and in every case for the homework, you're going to find the same thing. There's going to be no remainder. I change the signs, and I add, I get 0, and I'm done. So if you look at that, what is 20 plus 2? That is 22. It's the same answer that we got using normal division. So what we're going to do is we're going to use the second procedure to divide polynomials. So let's go back to your questions. I want to go to what we did in class is we went immediately to these questions at the end, and it seems that it worked pretty well. So let's go through the division of I. So we're going to set it up as long division. We're going to say x minus 2 divides into 2x to the third, a little fuzzy on my screen, minus 5x squared plus 5x minus 6. And we'll do the same thing we did before. We'll say, how many times does this x go into the 2x to the third? That is the same question as 2x to the third divided by x. Well, 2x to the third divided by x is 2x squared. All right? So now, if you recall, we multiply the 2x squared by the numbers in front. 2x squared times x is 2x to the third. A check that you did this right is that this number, this 2x to the third, should be equal. The first two numbers should be exactly the same, 2x to the third. So if it doesn't come out right, then you put the wrong number on the top. But we put the right number on there because we got 2x to the third. Now 2x squared times negative 2 will be minus 4x squared. Again, sorry about that interruption. Anyway, so now we change the signs and add, and we were going to get, of course, this cancels out. And in this case, we get I forgot to change the sign to this. We get an x squared. Negative 5x squared plus 4x squared should be minus x squared. Now the question, and then we're going to bring down the 5x. And then we start the process over again. How many times does x go into negative x squared? We'll divide it in, and you get negative x. Negative x times x is negative x squared. Notice they always match the first one. And I go negative x times negative 2 is a positive 2x. Change the signs and add. We have 3x. Bring down the 6, the negative 6. And again, we do the process one last time. X goes into the 3x 3 times, positive 3 times. 3 times x is 3x. And 3 times the minus 2 is minus 6. Again, we're multiplying by those two numbers there. Subtract, you'll get 0, no remainder. So the answer is 2x is going to be 2x squared minus x plus 3. One of the things that there's a second column on this paper where Mr. Hawk was hoping people would be able to recognize the following, and that is, once I divide this number in, that it means that x minus 2 times our answer, 2x squared minus x plus 3, is equal to what was underneath that, what was inside that sign, 2x squared, 2x to the third, sorry, minus 5x squared plus 5x minus 6. So, and that makes sense. I mean, if you think of something like this, if I took the number 2 and I divided it into 6, I would get 3. Well, 3 times 2 equals the 6. In the same way, I can say that this number here and this number here multiplied together should give me the number it's inside. So anyway, that's the idea. Well, anyway, we can continue this with some other problems. Let me go ahead and do. I can start you off with J, and hopefully you can finish it, and then you can even do K on your own. But as we move to, actually, let's go ahead and move to the easier ones on the previous page. So let me go back